Hello everyone and welcome back to our second practice video about angle of elevation and depression. So without further ado, let's now begin. So we have problem solving questions. Let's start with the first problem. Suppose there is a car in front of a building. The angle of elevation from the car to the tip of the building is 59 degrees. If we have the distance between the car and the tip, and that is 100 meters, then what will be the horizontal distance? So first, you visualize. Let's just say we have a car here, all right? And then there's like a building. And then here, according to the problem, the angle of elevation of the car to the tip of the building is 59 degrees. Right? Wait, I forgot to put the wheels. All right, there you go. So again, angle of elevation from the car to the tip of the building is 59 degrees. So that means you will form an angle above the horizontal. So we assume that this is the horizontal this is the horizontal area or plane rather. So we will draw an angle starting from the car from here going up. You will have 59 degrees. So from there uh up to the tip of the building. That's it. So now if we have the distance between the car and the tip, and that is 100 meters, so this is the distance between the two, then what will be their horizontal distance? So let's take a look the given here. So we have a diagonal line, we have the height of the building, and the horizontal distance between the car and that building. This is what we're looking for. Let's just say that this is x, all right? Let's represent what we're looking for as x. Now, we can say that this is a right triangle. All right. So we can rewrite this as this way: 59 degrees, 100 meters, then x. Now here, we're going to use a trigonometric ratio that consists of a hypotenuse side and an adjacent side. Remember, if you said adjacent side, basically it's a side that is beside the angle. All right. So x is your adjacent side because it is beside with 59 degrees. Now, what would that be? What would that trigonometric ratio we're going to use? So we're going to use cosine, all right? Cosine theta is equal to the adjacent all over hypotenuse. We are going to use this one because first we have the given angle, 59 degrees. Second, we have the hypotenuse, which is 100 meters. And lastly, we have x as our adjacent, the one we're looking for. So we're going to find, what's that again? Yeah, we're going to find adjacent. Here we can substitute. So we have a given angle of 59 degrees. So we can, let me just erase this one. So we can just simply substitute the theta as 59 degrees is equal to, so adjacent, that's your x, all over hypotenuse, that's 100 meters. All right. Now to find your x, we're going to put beside 100 to cosine. That's it. And there we go. Now we're going to use our calculator to find the answer for this one. So 100 cosine of 59 degrees. Wait, 100 times cosine of 59 degrees. At two decimal places, this is 51.50 meters. So the answer here is 51.50 meters. Okay, so that's for the first problem. Now next, suppose you see a tent and a tower. The horizontal distance between them is 4 kilometers. If the angle of elevation is 45 degrees and we ignore the height of the tent, then what will be the height of the tower? So again, you visualize. So this is the tent, assumingly, this is the tent, and then this is a tower. So let me just assume that this is the tower. It looks like an ordinary building, but You get my point. All right. So we have the horizontal distance between them. All right. So here, horizontal distance between them is 4 kilometers. So this is 4 kilometers. And here, if the angle of elevation is 45 degrees. Now here, the question is, where would we put 45 degrees? So according here, it's the angle of elevation. So meaning you're going to put the angle at the what? Very what do you call this one? At the how would I say that? Basically put 45 degrees above the horizontal line. Now the question is which part though? Should we put it here or should we put it here? Since we're looking for the I no 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 not this one. Wait. Since we're looking for the height of the tower, so of course we're not going to put the angle here, right? So let's just represent this as y, all right? We're not going to put the angle of elevation here, but rather here, right? We're going to put the angle here. So this is 45 degrees. There we go. Okay? So now we're going to find the height of the tower. Now, we can now represent this as a right triangle. So we have this one, y 4 kilometers, a right angle, and then a 45 degrees. So what would be the trigonometric ratio that we're going to use to find our y, or the height of the tower? So here, what we can do is we're going to use the formula of tangent. Okay? Tangent theta. Tangent theta is equal to the ratio of the opposite to the adjacent. What is the opposite side? Opposite side is non-adjacent, which is not beside to the angle. So this is your opposite. On the other hand, I told you the adjacent is beside the angle. So this is your A. All right. So here we can substitute our O as Y and our A as 4 kilometers. All right. Then the angle given here would be 45 degrees. All right. So now for us to find our y, we're just gonna put 4 kilometers beside tangent. So we have 4 times tangent of 45 degrees kilometers. So here, if we use our calculator, I think it's also 4 kilometers, but let's take a look. If we're going to use our calculator, this would be, yeah, 4 kilometers exactly. So this is 4 kilometers. Let me just fix the number 4. It looks like it looks like number 9 for some reason, right? So the answer here is 4 kilometers. Okay, so we're good to go. Now we're going to proceed to the next problems. Sorry. You are sitting on the edge of the rooftop of your apartment and you see a building in front of you but smaller than your apartment's height. If the angle between the edge of your rooftop and the edge of the building is exactly 60 degrees, then what will be their distances, horizontally and vertically speaking? So let's just, again, first step is to visualize. So let's just say this is your apartment, right? And let's just say this is you, okay? You're here, right? And then there is another apartment, okay? But it's smaller than your apartment's height. So let's just assume that this is the height of the other apartment, right? So you just assume, okay? Now, uh, let's try to let's try to zoom in. Like this is like our point of view. We're like very far from the two building. Now let's try to zoom in this. Okay. So let's zoom in. So assumingly, this is what it looks like. Okay. This is the height of your apartment, and then this is how small the other apartment is. Okay. Now this is you. Right. This is you. Wait, sorry, my mouse. Right. So let's take a look at the given. If the angle between the edge of your rooftop and the edge of that building is 60 degrees. So the question is, where would you put that angle? So according here, between the edge of your rooftop and the edge of that building. So let me just use different color. So it's from here going there, from the edge of that building. All right. Now, where would you put the angle? So it says here between the edge of your rooftop to the and the edge of the building. So meaning from here to there. So from the start, this is where you will put your angle, which is 60 degrees. Okay, this is where you will put the angle, right? It's 60 degrees. So here, we can now say that this is your angle of declination or angle of depression. Remember that angle of depression is an angle formed below the horizontal line of sight, right? Now, we're going to find their distances horizontally and vertically speaking. So here, we're going to find the distance horizontally. So from this point up to this point horizontally, I just represent it as x. Then vertically, so from here going down, we're going to find the vertical. So both of them, we're going to find it. Now, here's the question though. Okay, we have x, y. However, there's actually what do you call this one? We have x and y, so there's a chance that we're going to use two trigonometric ratios here, all right? But actually, wait, I actually forgot. There is supposed to be given here. Wait, sorry, guys. I actually forgot. There's supposed to be a given here. The given here actually, this is uh 15 kilometers. I forgive me, guys. This is 15 kilometers. I forgot to put the given here that the distance between from this tip up to this tip is 15 kilometers. I'm sorry guys. I actually forgot. All right? So now let's proceed. Okay, so here we can actually rewrite this in a right triangle form. So we just get this part. So we will have this as a result. So this is 60 degrees, x, y, then 15 kilometers. All right? Then we will use trigonometric ratios. If ever you're having a hard time, I suggest you should flip this one. Like flip it vertically. So this would become this 60 degrees, right? X, Y, 15 kilometers. There we go. So yeah, that's it. So here we're going to find X and Y. There's actually yeah, we're going to say trigonometric ratio, right? But there's actually a technique here instead. Because recall that when we learn about right triangle trigonometry, um, suppose we have a given hypotenuse here, and then you're looking for the horizontal and vertical component, all you need to do is use this formula. X times hypotenuse times cosine theta. X is equal to hypotenuse times cosine theta, and y is equal to hypotenuse times sine theta. So basically, if you have a given hypotenuse and then you're looking for the two components, you will use this formula. All right? So for you to find the vertical, just multiply the hypotenuse by the trigonometric function of cosine. And for the y, on the other hand, you will multiply the hypotenuse by sine. All right? So for us to find the horizontal component, we will multiply the hypotenuse, so 15 kilometers, times cosine of the given angle, which is 60 degrees. So if you're going to use our calculator, 15 cosine, it's exactly 7.5 kilometers. So this is 7.5 kilometers. All right? 7.5 kilometers. That's the answer for the horizontal distance. Now, for the y, you're just going to multiply the hypotenuse by sine 60 degrees. So 15 times sine of 60 degrees will give you approximately two decimal places 12.99 kilometers. And that's the answer. And that's it. Okay? That's how you find your horizontal distance and your vertical distance. All right, so we're good to go. Now, lastly, our problem is this. There is a crow flying to the direction that is opposite to yours. At an instant, the wait, sorry. At an instant, the distance between you and the crow is 3 kilometers. What is the angle of depression and elevation when the horizontal distance between you and the crow is 2.8 meters? So again, visualize. So this is you, and then there is a crow. So assume that this is a crow, right? So you're heading to the right direction, assumingly. Then we can assume that the crow will fly opposite to yours, which is to the left. Now, here's the thing. According here, the distance between you and the crow is 3 kilometers. So from here to there, it's 3 kilometers. Now, what is the angle of depression and elevation when the horizontal distance between you and the crow is 2.8 meters? So from here going to there, horizontally speaking, it's 2.8 meters. Actually, I was wrong here. This is not meters, by the way, right? Not in meters. This is actually in kilometers, all right? Forgive me, guys. This is in kilometers. Okay. So, where is angle of elevation and depression? So let's start first with angle of elevation. Again, angle of elevation is above the horizontal line of sight. So we can assume that this is your angle of elevation. All right. On the other hand, angle of depression is below the horizontal line of sight. Now, where should we put the angle of depression? Was it below this line or is it somewhere else? The answer is it's somewhere else, which is actually here, right? We can make an imaginary parallel line that is parallel to the horizontal distance here. So here we can form an angle at this point, which is angle of depression, right? This one. Now, if you're going to take a look, it seems like we have this what you call an alternate interior angle, where, for example, we have two parallel lines and then it's been cut by a traversal line. Let's just say the angle here is A, and then we have an angle here that is B. So if we have like two sides or two lines rather, and it's been cut by a traversal line, which is a diagonal line rather. Now, if you're going to take a look, we have an interior angle of A and interior angle of B. These two are actually congruent to each other. Hence, we can say that the measure of angle A is equal to the measure of angle B. Meaning, in this case or scenario, your angle of elevation is just the same as the angle of depression, right? It's just the same as angle of depression here. So now, whatever our angle of elevation will be, that will be also your angle of depression. Now, the question is, how are we going to solve it? Now, we can get a, what do you call this one? We can get a right triangle here. So I'm just gonna get this part only, like this part, where we include 3 kilometers and 2.8 kilometers, right? And an angle of elevation. So it would look like this one. So this is 3 kilometers and this is 2.8 kilometers. Then we have an angle of elevation. Now, what would be the trigonometric ratio we're going to use to find the angle of elevation? So what we can use here actually is cosine. Because here we have a given of hypotenuse as your 3 kilometers, adjacent as 2.8 kilometers. All right? And then we have a given angle of uh angle of elevation. So we have an angle hypotenuse adjacent, so we will use cosine theta is equal to adjacent all over hypotenuse. Now what we're going to do is we will find this angle. But before that, let's substitute. So cosine theta is equal to your adjacent, 2.8 kilometers. All over your hypotenuse is 3 kilometers. All right. Now we find our angle here. So all we need to do, just imagine where you put the word cosine to the right. All right. What's left is we have theta. Then here, just imagine there's like a negative one, but hey, this is not exactly negative one. All right. This is not negative one. It looks like one, but again, it's not negative one. Okay. So put here and put that yeah, that thing or that sign above the word cosine, then open parenthesis 2.8 kilometers, then all over 3 kilometers, then close parenthesis, okay? This is what you call inverse cosine or arc cosine, all right? Not cosine raised to negative 1. No, that's different. This is inverse cosine. Or if you're confused, just simply rewrite this way. Arc, then cosine, then 2.8 kilometers all over 3 kilometers. That's it. Now we can get the answer. So, uh, our cosine of 2.8 divided by 3. So this is at two decimal places, approximately 21.04 degrees. And that's the answer. All right. Answer for your angle of elevation and angle of depression. Again, angle of elevation is just the same as angle of depression. Therefore, their answer is 21.09 degrees. That is the answer. All right? And I think that will be all. That will be all our practice problems because after this video, I'm going to prepare a test videos. I think you know what test videos are. Basically, it's like um, a videos where we're going to answer problems. I think most of them are multiple choices, I guess. And yeah, we're going to answer multiple questions. All right. You know me. First, we have lecture videos. Then next, we have practice videos. Then next is we have overall test video that comprises all the things that we've discussed. This is to ensure that you guys are learning. You guys are what do you call this one? It's like um it's like it's a practice, but at the same time, it's like a self-assessment for you guys. All right? And I think that will be all. So next time, guys, the next video I'm going to upload in this series is the overall test of our of this topic, which is the six trigonometric ratios. And yeah, that will be all, guys. So see you soon.